Good afternoon, and welcome to APA's weekly webinar series. My name is Billy Zadig, and I'm the Codes Administrator for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to APA's webpage later this afternoon. You will receive a follow-up email in the next couple of days, the link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through December 2020, and most are open for registration. All attendees are in listen-only mode. Please type your questions in the chat box, and they will be answered in the order that they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. Professional continuing education and AIA-CLU credits are being offered. For AIA certificates, please send an email to Billy, B-I-L-L-I-E, @apa.org with your membership number. At this time, it's my pleasure to turn this over to Karen Sanchez, who will introduce our presenter for today's webinar. Karen, take it away.
Thank you, Billy, and thank you everyone for joining us today to learn about how to design a smart connected campus with STEM to business ecosystem model. Today's panelists are Dr. Nidal Boyana, Associate Dean of Research and Graduate Studies at Rowan University. And we also have Robert Boyginov, Key Market Lead in Higher Education, Siemens Smart Infrastructure. And I'll hand it over to our panelists.
Yes, good afternoon or good morning, everyone. This is Rob Boyagiev. We're thrilled to be with you today and present and hopefully help you design smart connected campuses as well as smart connected communities. So I'd like to just talk a little bit about our conversation today. Our communities in the U.S. are really going through a new area of transformation in terms of technology, where residents are becoming increasingly reliant on technology in their surrounding communities. We're seeing this particularly during the COVID response, and where cities have been, successful in responding to all the information and some of the systems that need to go in place to react to the pandemic. Also, we know communities are very unique. We see shifts in population, demographics, economic opportunity, and sometimes social unrest pose very, very difficult challenges for both universities in their community as well as the surrounding community. So our fundamental premise today is we believe that together industry, academia, and community should come together to work across these lines and help solve these societal challenges. We believe research combined with industry and government support at the university level is really fundamental to help solve these issues, and we believe the campus could really be the testing ground, because if we can get things done right at the campus level, we know we can scale those all the way out to the city level. So I'm going to turn it over to Nidal, and she's going to talk a little bit about this partnership focus with Siemens and Rowan University.
Okay, thanks, Rob. So my name is Nidal Carla Boinea. I'm the Associate Dean for Research and Graduate Studies with Rowan University. My research interests are in big data analytics, machine learning, AI. My lab is funded by federal and state agencies like the National Science Foundation, U.S. Department of Education, but also from industry like Lockheed Martin, and government labs like the FAA. I'm also interested in entrepreneurial endeavors. I'm the co-founder and chief executive officer of MRI Map LLC, a startup company in artificial intelligence for medical imaging. So as such, I'm tuned into federal funding for small business innovation research and small business technology transfer programs. So we are talking here about, our partnership focus with Siemens is at multiple fronts, at the academic front, but also at the research and innovation front. So innovation and research require funding. So we are going in funding in terms of public R&D funding, but also private R&D funding and membership. So in public funding, we are going with Siemens to acquire public funding. I'm going to give a couple of examples of federal funding that we are pursuing with Siemens. One of them is the flagship Smart and Connected Communities. It's a National Science Foundation program which was launched in 2016 to support research advances in technological and social dimensions at colleges and universities across the US with meaningful community engagement. In fiscal year 2017 and 2018, I'm pulling this from their website. This program, the Smart and Connected Communities program, invested $42 million to support 52 projects across the nation. We are also pursuing another National Science Foundation program with Siemens called the Civic Innovation Challenge, or CIVIC in short. CIVIC is a research and action competition within the Smart and Connected Communities domain. It is designed to build a more cohesive research to innovation pipeline and foster collaborative spirit between academia, industry, but also the community. CIVIC is introducing several unique features. So first, it is flipping the community university dynamics, asking communities to identify civic priorities that are ripe for innovation, and then to partner with researchers to address these priorities. It also focuses on research that is ready for piloting on a short time scale, where real-world impact can be evaluated within 12 months. It also requires the inclusion of civic partners in the core project team. So when I talk about civic partners here, obviously our stakeholders here include our campus community, student, faculty, staff, but also the administrators, the municipality of Glassboro, that's our township, the Southern New Jersey community, and also Siemens. So these are a couple of examples of federal public R&D funding that we are pursuing with Siemens. But federal funding also funds centers, tech centers. Here we have the NSF/SCC, Civic. Now, private R&D funding and membership, this type of funding we are seeking with Siemens, and I think there is a slide at the end where Rob will be able to talk about Siemens' share of funding.
Okay, next slide, please, Lynn. Nidal, why don't you cover the Rowan piece and I'll cover the point of view from Siemens, please.
Yes, sure. So Rowan, very quickly, so we are ranked number 21 best undergraduate engineering programs category by US News and World Report. Very quickly, we are a $15K per year average cost of attendance for in-state students. Now, in engineering, we have 4 research centers, in addition to the research labs, obviously. So the research centers represent our high priority research areas, and they are at the interface of research and development, industry collaboration, and federal and state level research work and development. We are focusing on AI, machine learning, cybersecurity, virtual reality, infrastructure and transportation. That's our 3rd center. We have a center in advanced materials and manufacturing, and a center in energy and sustainability. Now, the areas where we are focusing on with Siemens are the areas of energy and sustainability, and specifically making our campus a smart campus, basically by upgrading our buildings using technology, AI, by collaborating with Siemens, collaborating with the engineers in Siemens. So basically also bringing the academic research and making our campus a living lab, bringing the academic research into making our campus, a smart campus and community, a smart community.
Thank you. So from our point of view, from Siemens' point of view, why this relationship made sense from from the initial discussion. So very much, I know we have a lot of physical administrators on the call. So when we looked at kind of what, if you know Rowan, it's a pretty spread out campus. It's integral to the community. So we looked at it from a business point of view, like if we can vet these research areas with applied research at the campus level, find innovative ways to fund it, we'll call it the self-funding public-private partnership model, and actually start adopting some of these technologies, that there's a synergistic kind of benefit there. Number one, we're addressing technology to help the learning and the research process. So we're very much aligned with Rowan in their specific core areas of research, what Nidal said. So we felt we could strengthen those areas. The second area is, investment, right? What does that look like? We knew we can't just do technological upgrades for the sake of, technology. There needs to be, of course, there needs to be an ROI, and there needs to be an attractor for students. So we're using this campus model, if we can do this right, to further strengthen enrollment, faculty recruitment, etc. So that was the second part. The third part was, how do we actually start tying in the community? So, and I'm going to get a little bit more into that, but the STEM to workforce, that's a very important economic driver, so we can get the surrounding community interested in these engineering and science programs, and they can actually use the campus as an asset to help learn. So a lot of the assets we're talking about will be open to the public, and I'll get more into that. Next slide, please. So you may be asking yourself, this all sounds very theoretical, very aspirational. Let's get down to what makes it real. So what does Siemens bring? So our entire purpose, just first of all, is we have a business to society ethos where we really feel like whatever we do from a technology standpoint should have social good. We should be delivering social good. Our company was founded on that more than 170 years ago, and we have a tagline, making real what matters. So that's our purpose. The second thing is the way we're organized is in three areas. Number one, next slide, please. The first area, next slide too, please, Lynn. The first area is, a lot of our technologies focus around urbanization and smart cities. So we know, cities are complex systems, right? We want to make those cities less wasteful, operate better. So one of our core businesses is the smart infrastructure, and helping address some of these urbanization challenges, which could be transportation, which could be sustainability, which could be connectedness in terms of driving a better user experience from public services and public safety. So that was the first area that we helped Rowan. Next slide, please. The second area is climate change. So Siemens is in the business of, number one, reducing waste. I think the best quote I've ever heard is from George David, who's at one point was a chairman of United Technologies. A few years ago, the quote was 90% of energy still wasted. So we want to get in the business of reducing that waste. And students today are more concerned about the existential threat of climate change than ever before. Many universities, as you know, have adopted climate pact with their students and their community. So we reduce the waste, number one. And number two, we also look at electrification. We know our transportation systems are starting to go through very much systemic change in terms of electrification of vehicles. So that is an important component with the researchers at Rowan University. Next slide, please. And finally, we look at shifting demographics. This is the first time in modern history where we have 5 generations of people working in the workforce. So technology, we know millennials versus the older generation, everybody uses technology. We want to be sensitive to that. So we're going to have very defined use studies for all the different stakeholders, whether it be an older faculty member or a newer newer student, first-year student. We want to be sensitive to that. So that's another core area of the Smart Campus. And we do that with use studies. So what are our respective roles? So we'll get into that a little bit. So I want to give you an example where how this would play out in a real urban setting. So this is one of the things we built on with Rowan. So we're looking at the city of Troy, which is in upstate New York. So we're looking at, okay, if we're going to use the Rowan University or any urban campus as the laboratory setting, what do we need to help solve for? Well, many downtown areas, first of all, parking, right? We know it's very expensive to acquire land and build parking decks. So we want to look at smart transportation and parking, particularly the last mile. With Rowan, the leadership at Rowan was really concerned about, from a sustainability standpoint, why do we have, faculty or employees drive a mile to go from a gym from their classroom? Let's eliminate that reality, and let's look at better modes of shared transportation, just to give one example. The other thing is district energy. Rowan is unique because they have a district energy asset. So I'm going to get a little bit more how that's going to be in the learning tool, but we look at the economics of supplying campus-wide energy from a central utility plant with electrical generation, thermal and chilled water, and we look at all of the data. So one of the key researchers at Rowan, her name is Gia, she's actually engaged with her students to look at the energy modeling, real time, what can be done in terms of analytics to optimize the energy load balance. So that's another fundamental thing, to just give you a real example. Next slide, please. So Nidal, this is really your expertise. I'll turn it back over to you.
Sure. So indeed, Rowan is partnering with Siemens to conduct a testbed pilot, actually, where we are going to explore the technological but also social science dimensions of a smart and connected campus and community. So we would like to modernize physical assets using energy efficiency, transportation electrification, and this is, by the way, using expertise of our own faculty. So we have hired, at least in the College of Engineering, faculty with expertise in data analytics, AI, in transportation, in ITS, intelligent transportation systems, in cybersecurity. So these faculty members will work with their students and with Siemens to modernize our own campus. We are also going to integrate workforce development programs. These include from undergraduate and graduate level optional courses to certificates. Actually, we are creating, it's under review now, a certificate in AI and machine learning, and maybe we are thinking of also creating one in energy efficiency and smart grids. We are trying to engage the community, to promote participatory decision making. Like I said, these technologies will be integrated with community engagement initiatives. We are also, in this sense, we want to create, again, the notion of a living lab that could also serve as a data warehouse that tracks sustainable development goals, like environmental and economic impacts. So these are all what you see here in the slide. These are areas that Rowan University we've invested in. We've invested in faculty, startup, but we are encouraging these faculty to work, obviously pursue their fundamental research, but also work with our private partners, our industry partners. The College of Engineering only, we have CRADAs with more than a dozen of industry, local industry. GA is our faculty who works in distributed energy systems, energy storage, smart grids, Ghulam, myself on data analytics, artificial intelligence, computer science, folks on cybersecurity, myself and others on autonomous robots. But the idea is how to bring these areas to upgrade our campus and also engage the students and the community, and attract, obviously, federal and private funding to achieve this. Next slide.
So what does this look like from a career pathway, right? So what we're trying to do is strengthen community through education and through workforce preparedness, career readiness. So we look at all of these different areas when we want to be very mindful of how do we engage with local institutions, namely K through 12, the local public schools. So part of our work here is we have to engage with our school district partners and community to help them start understanding where the jobs are, the future of work. So these are 5 areas that we're going to focus on, specific job opportunities. So let me give you an example. Maybe someone comes from the local community that wants a 2-year degree, particularly maybe in advanced energy. So we would work with the school district at the high school level so they learn about electrical vehicle maintenance. That's a big deal right now. We're putting more electric vehicles on the road, but our workforce is not necessarily up to speed, and that's a very much a technical, computer-driven skill set. So we help inform that. Siemens is in electric vehicle systems, AV, so we bring some credibility there. Advanced energy, when we talk about a tech valley, Camden has a vision to becoming a smart city. What does that mean? Everybody uses that term. Well, we want to work with the local leadership to help define what that means from a job growth standpoint. Solar technicians, microgrid technicians, etc., to give you an example. And we do this deliberately with the entire STEM ecosystem. So the parents, the local public education leadership and teachers are engaged, and very much what Nidal said, they can get certified at a high school or a 2-year graduate level. Then Rowan they very well may finish their academic career by getting their engineering or 4-year degree at Rowan. So that's all been mapped out in this arrangement. Thank you. Next slide, please. So this is also Nidal's piece.
Yeah, sure. So basically this slide, like I said early on, our partnership with Siemens is multifaceted. So obviously there is the academic curriculum education side, and there is the research innovation IP side. So to make them just 2 sides. So at the academic front or the education front, right, we would like to have our students, undergraduate and graduate students, have the opportunity to intern with Siemens. Same for PhD students. These are called experiential learning opportunities. Like the new model of forming PhD students is not only to work on that theoretical topic, but also work or interface with industry, government labs, have experiential learning opportunities. That applies at the undergraduate and graduate levels. Have also Siemens integrated into our clinic project. These are what they are called in other universities, capstone projects, right? These are the final year undergraduate projects. So Siemens will come up with a real world unsolved problem that our final year undergraduate project, undergraduate students, will work on. So that is all at the, we can even look at the opportunities. We are still discussing opportunities of co-op with Siemens as well. So this is all at the educational academic front. At the research/innovation R&D front, we have an MOU with Siemens that was signed by both parties. We are going and actually together writing proposals to the federal government here, National Science Foundation, trying to get funding for our faculty, but also for some engineers in Siemens to pursue this idea, to pursue the Smart Campus Initiative. So we have government research collaborations, the IP, university-funded research. Obviously, what you mean here is all of the startup or the internal funding that we provided our faculty so that they can start working on this SMART initiative project.
And so when we're talking about industry, the idea to strengthen the community, again, that's one of the key themes. It shouldn't just be about Siemens, it should be about the whole tech ecosystem. So, you know, we see pockets of innovation in university cities, Cambridge, you know, Palo Alto, you know, some of the Boston areas, right? We think it shouldn't be limited to those areas. Innovation could be open to all. The way we do that is the idea of getting these startups, getting the mentorship, getting the investment necessary so they can bring their, you know, their entrepreneurial ideas and innovation to market. So that's a key piece. So when we're doing these projects, and maybe they have, give you an example, maybe they have a sensing technology, and we're talking to one startup that's doing some unique, you know, indoor air quality sensing that's kind of game changing. We want to bring them and help cultivate that innovation. And then if you look at kind of like the multiplier effect, one PhD created out of Rowan creates 10 technical jobs. So this is nothing new in America. We did this great during World War II. But what's kind of happened is, unfortunately, a lot of the investment and innovation is getting led by the tech center, Silicon Valley, New York City, Boston. We want to break that model. We want to bring it to other universities where there really is no monopoly on innovation, but we have to help design and get that impact. So that's kind of what this is about in a nutshell. Next slide, please. So, you know, what does that look like from a hard asset standpoint? So, you know, one of the coolest things I think I heard from Rowan was the VP of facilities and operations, Joe Campbell. He said, you know, we turn our liabilities, our central utility plant. What if we turned our liabilities into learning assets? We're an engineering school. I happen to be a maritime engineer, so everything I learned, I had to go out to sea and learn and practice on boilers and turbines and propulsion and whatnot. So it kind of resonated with me. I said, let's get our engineering students. And quite frankly, if we're honest, there are some engineering programs where it's been too theoretical. They may not know how a boiler works other than what they've seen in a textbook. So we're changing that model. We want a living lab where the students can actually work on design projects, you know, with museum-like quality, you know, assets in terms of, you know, you have an open window, open environment. And to give you another example, next slide, please, Lynn. You know, what if we had digital assets where they can start learning of how energy is produced? Again, open to all, so various tracks. And this idea, this is an example of a geothermal plant we built up at Durham College in the Ontario, Canadian area. But the idea was originally born by the Crystal in London, where it was basically a smart cities museum where students and citizens can learn everything about sustainability, to infrastructure, to transportation modalities, and how to make a city more connected. So we really very much want the university to be that setting where it's open to all, right? Particularly with our STEM to workforce piece and engaging community, and students get excited about those kind of field trips. So this is a little bit more like we put the student in the center of this, right? So when we build their career DNA, we look at all the assets in the area. You know, South Jersey is a very strong STEM ecosystem. A couple school districts, Delran, and Pennsauken are very, very much getting around this, getting STEM introduced at an early age throughout their school careers. So we're trying to, we're just part of that. We don't run that. We're just part, we help catalyze that, particularly with Rowan in the community. So there's all kinds of great opportunities with some of the learning assets in that community. Next slide, please. So we've talked a lot about the theory and some of the research piece. We want to talk about how would you actually implement this. So I'll just go through our example that Nidal and I had. We originally had an initial discussion, kind of a concept paper, where we pitched this to the provost and his team. And we got some engagement, right? From that engagement, we said, okay, let's structure an agreement, which was a memorandum of understanding, where we could actually, operationalize some of these topics. So right now we're in the third box, developing the business case. If the business case makes sense, and we're pretty sure it will, we will go into the next phase, which is very much what we call technology and energy master planning. A lot of engineers on the call know what I mean. So we want to develop a campus-wide energy plan that goes through, it's very much co-authored. Everything we do here is done at a co-creation level, where the use studies that the faculty will have an input in, since they're the ones who actually have to, study, research, and teach in those buildings, as well as students, as well as the people who run them. Everybody's at the table. Where I found things fall through is, when things are done in isolation. So this is very much a co-creation model. And then eventually we'll get into an investment decision and procurement model. Many times we will have to compete for this work, no secret there, but this is a public university, so we'll have to compete. But we want to win on the merit of our, the value we bring, not just the transactional piece. Next slide, please. So what would it look like? So if you look at the individual building blocks, so first of all, we try to build from the utility level. So we talked about, for instance, distributed energy. So we start with base site utilities. We look at what's needed from an infrastructure in the ground standpoint, and different distributed energy systems throughout the campus. Then we move on to, okay, what would you need in technology for your parking? Then we look at energy utilities in terms of, okay, do we need distributed energy? Do we need actual decentralized energy? Rowan's a unique campus. Besides, they have a big appetite for renewable energy. So we look at potentially offsite renewable energy and solar. And then we look at the individual campus blocks. For the purposes of this partnership, we're at phase one. We're going to use the NSF to pilot 6 buildings. If that goes well, we would go and build into the other buildings. Next slide, please. So we look at, we talk about IoT and all the different technologies that are going in buildings. We know there's more technologies than we can count, right? But the idea is we really much use these technologies to help, again, inform research, inform the learning process, and ultimately create a better learning environment. Many times with deferred maintenance and just general campus budgets, sometimes buildings haven't kept up to what's needed from a learning perspective. We're trying to solve for that. Next slide, please. So, this is kind of like the financial, how this actually works. So again, we're not asking for more money. We're just looking for the opportunity to unlock more value out of the buildings. So it's a little bit of an ESCO model for people who've done, who have worked on that model before. So we're looking at very much monetizing some of the operational or utility savings and then reinvesting. What's unique about us is we not only could we bring some of that utility infrastructure funding, but we also could use those NSF grants and various grant things. So when you look at what a $1 million grant does in terms of implementation, it makes the project much more attractive from Rowan's standpoint, because it's other people's money. So we're trying to leverage all of those and to create the best possible financial outcome for for the university without any out-of-pocket capital if we take ownership of some of these technologies and basically do a lease back or some sort of ESCO model. Depending on the technology, we can do both. So that's pretty much, that's the model. I'll pause there because we've been speaking for about 30 minutes now, and I'll pause, and Billy, however you want to open it up for Q&A.
Okay, right now we don't have any questions in our queue, but if anyone who would like to ask either Robert or Nidal a question, just type it in the chat box. I think you gave everyone a lot of things to think about. Okay,
well,
yeah, our first question. We have a couple of questions coming in. It took a little bit. How would this new partnership model affect accreditation?
That would be better for Nidal.
Sure. It will not affect accreditation because accreditation is here in this sense for engineering ABET accreditation. So it has to do with the core courses in undergraduate engineering education. So here, what we are going with Siemens is at the research and innovation level. When students, so when I talked about the curriculum side, I talked mainly about the experiential learning. I talked about possible internship opportunities with Siemens. That does not affect accreditation. I talked about optional courses and certificates, and these do not count towards graduation. Only a certain number of them counts towards graduation, so they do not affect accreditation either. Right. So here we're at discount of the capstone level project, and what affects accreditation is for the capstone project, for example, there has to be design components, right? And obviously, all of those will be there. But in short, it does not affect accreditation because we are not changing the core undergraduate curriculum.
And like from an industry point of view, we're always, one of the gripes, from industry, particularly some of the engineering design shops is, and I'll just be really frank, because I've heard this from some partners at engineering firms. We're paying top dollar for engineering students, but those first 2 years, there's still a lot of training or retraining involved to get them field acclimated. So from our point of view, the more we can expose engineers or scientists to real life problems and solving real life issues we talked about earlier in the conversation, they're more employable. That's why we invest in this model. They're more employable, cuts down on some of our training costs. And engineer grads, that's a pretty big investment, right? So, and they're also probably going to be a little bit more loyal to to the Siemens environment because they've seen some investment in their career and their education. So just keep that in mind as well. I know that it's not an accreditation question, but it's kind of a certification answer in terms of how we look at it.
Let me just add one thing. So let me just follow up with one thing to remember. So we were at the 5 engineering departments. We were accredited at Rowan in 2018 with the 6 years, that's the max. And actually, I remember very well the fact that we were offering capstone projects, final year undergraduate project in collaboration. Most of them were in collaboration with industrial partners. These actually were strong points for us. They really, really liked that model. So if for anything, it helps our accreditation.
Thank you. Next question, how does Siemens support integration with existing systems?
That's really the tenet of smart and connected, right? So we have a lot of disparate data systems out there. So one way, just real example is if it's on the network and if it's a backnet protocol, we can grab it. You know, our Desigo enterprise level head end could grab many third-party systems. Legacy systems are a little bit more challenging. It kind of depends where they're at in terms of their protocol. We have seen, you know, legacy systems, you need translators. So if I may, like, I'll give you, so if it's a newer system and you want to extract that data from an optimization or an energy analytics you know, strategy, that's fairly easy to do. We could, if that data is on the network, we can grab it. And there's a lot of other industry in the building automation world that can do that. If it's a legacy system, sometimes you have to translate that data with, you know, for the lack of a better term, a black box. There's companies that do that. Tritium's, you know, made a career, made an industry out of that. Excuse me. So that's one way to do it as well. But we've seen all kind of sizes and shapes, and you know, the point is get the data and get it as cost effectively as possible.
Okay, thank you. Would curriculum be specifically, sorry, my screen just jumped. Would curriculum be specifically designed around each academic field? Could you give an example from internship to course of study to graduation, finding a job in that particular field?
Who should go first on this one?
Oh, yeah, sure. So hold on. If I understand, I hope I will understand the question correctly. So here, so we were talking about internship, curriculum, but also certificates and getting a job. So I actually went and drove to Princeton, right, where Siemens is. And right, they also came to Rowan to talk about the idea of workforce development and having students intern, but also hiring our own graduate students. So for now, because Princeton, they are the R&D branch, right, of Siemens, they were mainly interested in graduate students and PhD students. They were actually telling me that they hire European graduate students, and they would like to have, they hire actually as interns. They would like to have, and we are like 40 minutes away. So we are still developing that, but basically the idea will be, we talked about some areas of intersection. This include data analytics, IoT, Internet of Things, machine learning, but also cybersecurity, also advanced manufacturing and digital twins. That's another area of interest, and power, advanced power systems and smart grids. So we are still in the process of developing a formal collaboration. We only have like a vague MOU, right? But the idea is to have our graduate students, like have Siemens have positions for, let's say, you know, 3-4 graduate students that intern with them in these area of interest. Now, something that we are organizing that hopefully will facilitate this is a TIM between Rowan and Siemens. A TIM is a short for technical interchange meeting. So that's a meeting, and I did this with the FAA a few years back, where we will, let's say, invite 10 or 20 managers and engineers at Siemens in relevant areas of interest. And then we have same thing, 10 or 20, 30 faculty in those areas of interest, and everyone will present 5-minute presentation of their research expertise. And then we'll have a networking session. And the idea is to match or pair Rowan researchers and faculty with Siemens developers and researchers and managers, so that they can work on you know, a research project together. They can sponsor a graduate student or an final year undergraduate project, or they can pursue together R&D federal or state funding. And then once that is done, maybe I think experiential learning opportunities for students will be easier once there is a relationship between a Rowan faculty and a program manager or an engineer at Siemens. If that talks about the internship part. So what other part, could you please repeat the question, other part of the questions that I made? So internship, curriculum, and how do the student find jobs, I think at the end, right? So we
correct.
How it's, okay. So we introduced a co-op with Lockheed Martin, for example, and we did actually a certificate with Lockheed Martin that Lockheed Martin engineers are teaching. It's a certificate in combat system engineering. So this certificate has, for example, 4 courses. 2 of these courses count as optional courses. They may count towards graduation, but 2 others they don't. However, they count towards the certificate. Now, once you complete the certificate during your BS study, you have, in a sense, more chances to be hired by Lockheed Martin. The same thing for co-op. We have changed our or facilitated co-op opportunities for our students, right? We put they can co-op during the fall semester, and then we can squeeze in some of their classes in the summer. We can work with them in the summer or winter breaks, to finish other courses. But we were able to accommodate a co-op with Lockheed Martin for our students. So obviously, most students does co-op interns with Lockheed Martin and takes the certificate. That this Lockheed Martin certificate, the opportunities to be employed by Lockheed Martin, right, becomes greater, becomes higher. So we would like maybe to have develop a similar co-op opportunity with Siemens. Like I said, now we were focusing on the R&D funding. We just started the discussion about the curriculum and education side, but co-op certificates, and then the student simply becomes highly competitive for Siemens or for that industry for which they did co-op with, and they took their certificates.
Billy, I'd like to answer a little bit too, just from Rowan's. So if you look at Rowan there's a main campus, but it's a system, right? So there's associated campuses, right? That when we look at hybrid learning, many students may want to look at a 2-year degree, right? They may want, and then finish main campus, get some work experience. We're seeing more and more hybrid models. Not saying that's exactly what Rowan wants to do, but if you just look at it from a student's perspective, if they wanted to get something like a 2-year degree and have a job, like I talked about earlier, digital badging, certifications, all that is very, very marketable from an employer like Siemens. We know they've been trained on whether it be our software or technically like building automation, whatever it may be. The more we can build those relationships with the community, the better it is for the community, the better it is for Siemens, because quite honest, it's an aging workforce. There's a lot of drivers why we have to do that. And on top of that, it provides a little bit more loyalty in terms of tenure and keeping that employee within Siemens. So that I see digital certifications and badging and all that going on in concert with just the traditional 4-year degree, just because people are becoming life learners. They may not want to take college all in one 4-year swap, but we still want to be mindful of the people who want to do the 4-year degree, and we support them as well. So that's how we see it.
And indeed, let me follow up. So it's again this idea of stackable credentials and certificates. It's becoming quite important, this lifelong learning. So I want to say at the university side, it's very important to be entrepreneurial at the university side, flexible and agile, of course, while keeping accreditation requirements in there. When I develop a certificate, right, for Lockheed Martin or for Siemens, I am not, I'm still keeping my accreditation requirements, right? Like some courses may count towards the accreditation, and some don't. They only count towards the certificates. When we fit in co-op opportunities, we are still keeping our accreditation requirement. But it's very important that the university or the academic side is entrepreneurial, because at the end we are forming these students for the market, for the industry, for future jobs, right? We are not just forming them for the so we need to interface with the jobs of the future and with the industries that are at the forefront of innovation, so that our curriculum catches up. So it's very important that accreditation does not mean stagnation in curriculum.
Okay, thank you. Next question. Rowan has obviously been forward-thinking in terms of partnering. What do you recommend in terms of approaching a very conservative state government with lawyers who are not interested in facilitating change?
That's it. I think we both can answer that. I mean, maybe you go first, Nidal.
Okay, so we do work with the some state government, mainly, for example, New Jersey Department of Education. I work with them myself, mainly the Department of Civil and Environmental Engineering. Work a lot with them. So we work with them mainly through, again, the R&D public opportunity when there is a request for proposal. But we also, there is quite a bit of politics and lobbying. It's not only that there is an RFP. In some cases, there's a request for proposal. You write and apply, competitive proposal, and it gets funded. But in most of the cases, there are, for state, I'm talking about the state here, okay, some politics and lobbying going on. So, for example, you have to partner with other universities, or the state would like to see, or one needs to be aware of these politics. But if the state put an RFP, they really expect no more than one or two, or so that they really expect that all other regional universities collaborate. So you need to be, open, reached out to other regional or in-state institutions, try to collaborate with them and try to say, here, we have one cohesive proposal that addresses the problems that you are trying to solve, and we're going to all work together. And at the end, that's where the state is funding the state institutions. But yeah, there is quite a bit of, I would say, politics backdoor and lobbying. Again, you need to keep pushing. So yeah, it's not like NSF or NIH where you just submit competitive proposals, or these SBIR, small business federal funding. State, you need lobbying. You need to work with whoever the lobbying office at your institution, and you need to understand the framework of their mind. What do they expect really from this, let's say, RFP? So we've gotten quite a bit of funding from the state, but we do understand their expectations. It's not written, but there are some, between the line expectations. Rob?
Yeah, that's good. No, I agree with all of that. I mean, politics aside, there needs to be wins for elected officials and governments and all that. But from our perspective, it was intention, right? It was intentional where we came in, we pitched this at a pretty strategic level where we were very upfront about our intentions. We said, again, if you remember that slide, strengthen mission, strengthen their research mission as well as their educational mission. And we were dealing with some people that really wanted to delve into that. So what is your intention, right? So we try to give some very specific examples, which you've seen today. So I think the message was well received. When it's well received, when you come with good intentions, it makes it easier. I've been guilty, or I've seen others being guilty, where they come about it, they talk partnership, but it's too transactional. So it just feels like a contract. This is, and I want to stress from Siemens' point of view, this is all about long-term partnership. Now, We're in a public procurement. We have to comply. So when we structured this MOU, if we want to get into the really kind of the nuances, we still have to earn the right to do business with Rowan. This is not a sole source. This is not a you know, get around procurement. It's, you know, because their lawyers were involved too when we structured this. So we're also mindful of all compliance, obviously. At the end of the day, we have to create value, and that's our intentions. You know, I call it like a Justin Bieber. Shower them with your intentions. If they're noble and they understand, you know, there's conviction and commitment, and it was, you know, I try to lead a whole team, and we brought a lot of different facets to this. I think they're seeing the intentions are, you know, are good, and we're committed for a long term. So that made it a little bit easier to answer your question about some of the skepticism at the procurement or the legal level. I could just tell by the tone of the voice, because I was on the phone with the lawyer. It made it a little bit different, because I've been part of those conversations when we're just treated, quite honestly, like a vendor, and that's not comfortable. So that's just my perspective.
Okay, thank you. Another question, comment. Very inspiring and holistic approach. Is Siemens planning similar partnerships with other institutions, public and private?
So the answer is we've always engaged in this type of university relations. So if you look at, so the answer is yes, and this is not the first time. We're just trying to do more of it in light of what, you know, what institutions need in the job market. So the answer is yes, and I realize I may have some competitors on the phone, but you know, this model is good for, it's good for society in general. Everybody brings different industry experience to the table, depending on the industry, excuse me, the education's mission and their core expertise in R&D. So we've done this. We want to do more of it. We think it's the right model, because it does benefit the community, and ultimately that will win. So that's, and again, business to society, right? So that's why we do it.
Okay, well, thank you. We're almost out of time here, so I want to thank our panelists and Lynn and Karen from Siemens for all of your help with putting this together. I want to thank the people who took time out of their busy schedules to sit in with us today and learn about this. And if you have any questions, please feel free to reach out to our presenters, or you can send me an email and I can connect you with our presenters. So thank you so much for attending. And until next time, have a great afternoon. Thank you for all. Bye-bye.